In this topic, we're going to explore how we describe a moving object in more than one dimension. That's going to be our new exploration. Most of us have seen at this point how we can look at functions where we have position measured as a single variable, say x, as a function of time. And classic examples of these in physics are, of course, a little cart, where we have it moving left to right, and x is the position, and it changes over time. And we can, of course, study velocities, accelerations, and so on in that context. If we wanted to get more exotic, we could have done it with an inclined plane, and we get nice studies in friction and so on in that environment. But what about something where we have a car going around a track, something in more than one dimension? Well, we're going to have to explore how we both represent and work with questions about position, velocity, and acceleration in that new context and how we formulate that mathematically. To help motivate that, let's look at the questions involved just in studying a relatively simple question of a spaceship moving in space. We're going to be using angle brackets that are going to indicate a vector as our position. And we're going to see it has multiple components, so not just one x, but rather here an x and a y and a z that are all changing with time. And as soon as we have that formulation, we can ask relevant follow-up questions. What would this trajectory look like if we graphed it? How can we visualize this? Because that's where we get a lot of our intuition from, is that graphical sense, in addition to the calculations we can do with the algebra. Then we get into questions about derivatives. So speed. Well, speed is magnitude of velocity. How do we get a magnitude of a velocity when there's more than one velocity? There's velocities in different directions. Can we go further? Can we talk about an acceleration? And can we talk about the magnitude of acceleration? And how much can we reuse from our earlier study of derivatives to be able to compute these kinds of values? And moving more into the physics domain, if we knew the trajectory that we were on and we were let go at some point, well, then Newton's first law kicks in, where no forces are acting on us anymore. And so what trajectory are we going to be following after that instant? We're going to follow a straight line path. How do we quantify that? How do we represent that mathematically? We'll answer all these questions going forward.